Good morning, guys. So today we are going into Chapter 7, Section 2 notes. This is properties of parallelograms. So remember, in our last period, I had you guys do that exploration activity. You had to graph your lines, and then based off of those lines that you graphed, you then had to find your slope and your distance. So that stuff kind of comes into play today, and hopefully it kind of makes a little more sense as to why I had you do that in the first place. So with parallelograms, we do have some definitions and some theorems that we need to take note of. So in our vocab today, we have a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. Remember, a quadrilateral is a four-sided shape, so it can look really any type of way, but a parallelogram is just a four-sided shape where your opposite sides are parallel. The parallelogram opposite sides theorem states that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So now we know that opposite sides are parallel and our opposite sides are congruent. And then, very similarly, we have the parallelogram opposite angles theorem, and that states if a quadrilateral is a parallelogram, then its opposite angles are congruent. So in a parallelogram, it is just important to note that opposite sides are congruent and opposite angles are congruent. So hopefully when you did that activity on Tuesday, you noticed when you did the distance formula for those sides, you could see that the opposite sides did have the same measurement, or at least they should have, as long as everything was graphed and equations done correctly. Okay, so we are going to use this knowledge of these different theorems in order to solve for angles, sides, and missing variables. So in these first two examples, the first one says to find the values of x and y in the image off to the right. So they tell us that our opposite sides are parallel. That's what those red arrows tell us. And we know from our theorems that opposite sides are congruent. So that means that AB here is congruent to DC, right? Those are opposite sides. So we can say x plus 4 equals 12. So then to solve for x, we just have to subtract 4 from both sides. And we get that x equals 8. Also from our theorems, we know that opposite angles are congruent. So that means that angle A and angle C have the same measure. So in this case, there wasn't really anything extra we had to do. We just know that y equals 65. All right, so for number 2, we use those same methods. So opposite sides are congruent, opposite angles are congruent. So if opposite sides are congruent, that means KJ, which is 18, is equal to LM, which is y plus 3. So to get y by itself, we subtract 3 from both sides, and we get y equals 15. And then our opposite angles of 2x and 50 are also congruent. So 2x equals 50. We divide both sides by 2 to get x alone. And we learn that x equals 25. All right, so then we have a couple more theorems. So we have the parallelogram consecutive angles theorem that states if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Remember, consecutive angles means that they are next to each other. So if you have one angle, then your next angle is either to the left of it or the right of it, or like above it or below it, depending on where your angle is at. So supplementary, also remember, means that they add to 180. And then the parallelogram's diagonals theorem states that if a quadrilateral is a parallelogram, then its diagonals bisect each other. So if diagonals bisect each other, that means that it divides them in half evenly. Remember, that's what that word bisect means, is it cuts it in half evenly. All right, so using that new knowledge, we are going to solve a couple of these other problems. There is a small typo on these problems that I'm going to tell you about as we read through it. So it says, as shown, part of the extending arm of a desk lamp is a parallelogram. So I'm going to kind of zoom in. You see how this is outlined in red? That's what it's referring to that forms a parallelogram. The angles of the parallelogram changes as the arm is raised and lowered. Find the measure of angle BCD when ACD equals 110. So here's where the issue is. So there is no angle ACD in this picture. It should actually say angle ADC. So it's talking about this angle right here. Okay, so if we need to find the measure of angle BCD, so that's going to be this angle here, and they tell us that ADC is 110, those two angles are consecutive, and we know that consecutive angles are supplementary. So in order to find that missing angle, that means that our angle of ADC plus some unknown angle measure, that's what we're trying to find, has to equal 180. So then all we have to do is subtract 110 from 180, and we get that that missing angle measure is 70 degrees. So BCD is 70 degrees. All right, and then we have the same issue in the second example. So ACD, again, should be ADC. And so it says, in the previous example, find the measure of angle BCD when ADC is twice the measure of BCD. So we're going to say BCD is X. So when it says the previous example, it just means this picture. It is not at all referring to the numbers that are there, just the picture that we have. So BCD, we don't know what that is. And then it tells us that ADC is twice the measure of BCD. So that's going to be 2x. And again, these two angles are supplementary, so that means they have to add to be 180. So that means x plus 2x has to equal 180. And so x plus 2x is 3x, which equals 180. And then to get x alone, we have to divide both sides by 3. So we get x to equal 60. They asked us to find the measure of angle BCD. Well, in this case, x was BCD. So that is our total answer. It is 60 degrees. All right, and then the last thing that we have to go over today, a lot of you had questions about this on Tuesday, is the diagonals of a shape. So that was kind of new to you guys, and this will hopefully make more sense from Tuesday. So it says, find the coordinates of the intersection of the diagonals of parallelogram LMNO with vertices at 1, 4, 7, 4, 6, 0, and 0, 0. So the first thing we want to do is plot those 4 points to actually make our shape. So we have 1, 4, 7, 4, 6, 0, and 0, 0. So you have L, M, N, and O. And then we connect those points to form our parallelogram. And then it asks us for the coordinates of the intersection of the diagonals. So the diagonals would be from L to N and O to M. Now you can't just look at this picture and try to look and see where that intersection is. You actually need to do the math to show me that intersection. But so what you are looking for is the midpoint of those diagonals. So remember that our midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So we need to find the midpoint of LN and the midpoint of OM. And these should be the same, but that's why we do both of them, just to make sure that we did everything correctly, that we did the math right on both things. So LN, so the x of L is 1, plus the x of N is 6, divided by 2. The y of L is 4, plus the y of N is 0, and divide that by 2. 1 plus 6 is 7. 7 divided by 2 is 3.5. 4 plus 0 is 4. Divided by 2 is 2. And then we just double check with OM, make sure that we get the same thing. So our x of O is 0, plus our x of M is 7. Divide that by 2. And then the y of O is 0, plus the y of M is 4. Divide that by 2. And we get the same thing, as we should, because that is where they cross. So that is the intersection point for the diagonals. And then our last problem, same thing, find the coordinates of the intersection of the diagonals of parallelogram STUV with vertices at -2, 3, 1, 5, 6, 3, and 3, 1. All right, and so again, we are looking for those diagonals. So especially here, notice that my stuff does not look great where those lines lined up. So you can't always just look at where they intersect and pinpoint that spot. But it is nice to kind of compare to when it comes to finding these. So we have to find SU and TV. So we do -2 plus 6 divided by 3, and 3 plus 3, oh, not divided by 3, divided by 2. -2 plus 6 is 4. 4 divided by 2 is 2. 3 plus 3 is 6, and 6 divided by 2 is 3. And then for TV, we do 1 plus 3 over 2. And 5 plus 1 over 2. 4, so 1 plus 3 is 4. 4 divided by 2 is 2. And then 5 plus 1 is 6. 6 divided by 2 is 3. All right, and so our point of intersection for our diagonals did match. It is at 2, 3. And if my lines were a little bit better, you'd be able to kind of see that over here too, that would be at that spot. Okay, so that is our lesson.